So after watching the review of what you learned in grade 9 with respect to scatterplots and lines of best fit, I want to review what we've done so far. And up till now, we've been looking at univariate or one variable descriptive statistics. And so this tells us something about the distribution of a single variable, and univariate descriptive statistics includes mean, median, and mode, which measures the central tendency of the data, minimum, maximum, lower quartile, and upper quartile range, which looks at the range, also the interquartile range of the data. And this all tells us something about the spread of the data. And remember that we also include variance and standard deviation when we talk about spread of data. So now we've also looked at graphical ways or displays of distribution of a single variable, and an example of that would be a frequency histogram. So now we want to consider the relationship between two continuous variables, and we're talking in this case, we're going to call this bivariate or two variable statistics. And recall that a continuous variable is a numerical measurement that falls along a continuum. For example, height, weight, systolic blood pressure, cholesterol, household income, and white blood cell count, and so on. So now, one easy way to summarize a relationship between two continuous variables is to create a scatter plot. And a scatter plot is a two-dimensional graph. The independent variable goes on the x-axis or the horizontal axis, and the dependent variable, the y, is represented on the vertical axis. So here we've got an example of a scatter plot. And in this case, we might have, for example, cholesterol levels, and we might look at what the blood pressure is of the individual. So each symbol here represents a subject or a measurement. So if this was cholesterol levels here, this would be the cholesterol level of a single individual and the corresponding blood pressure of that individual. The position of the symbol indicates the subject values of x and y. So for example, here, this would be again the cholesterol level of an individual, and this would be that individual's blood pressure, if that was what x and y represented. So scatter plot then is a graphical method of showing the joint distribution of two variables in which each point on the graph represents a pair of values. The independent variable is the variable whose values are arbitrarily chosen by the experimenter. The experimenter can choose various altitudes here in order to measure temperature. So if we're looking at if the person is interested in the temperature, the mean annual temperature at various elevations, what they'll do is they'll choose a variety of elevations and take measurements there. So the dependent variable is a variable whose values depend on the independent variable. So in this case, mean annual temperature depends on the elevation of that area. So a line of best fit, again, is a straight line that best represents that particular set of data. And so if we look at an example here of the year and the winning jump in the Olympics, you'll notice that they more or less follow somewhat of a linear pattern. And so the line of best fit passes through the majority of the points. So that we're going to talk about this in a little bit about how you can actually mathematically do this. But right now, I want you to be able to draw a line of best fit based on just eyeing it up. And you're going to have equal numbers of dots and spacings above and below the graph. And this is a little bit of a guesswork at this point in time, but I want to talk about this and how Excel can give you a better line of best fit. And we'll use that coming up very shortly. And so again, correlation is the apparent relation between two variables. We can have a strong positive correlation, which would be extremely perfect positive correlation would be all the points line a line that goes up to the right, so that as one variable increases, the other variable increases. And so this would be an example of positive correlation. I wouldn't call it strong, I would call it positive, and I'll talk about that in a little bit about how you can classify varying degrees of correlation. So what I'd like you to do now is you're going to create, using the link I gave you for a piece of grid paper, you're going to create a scatter plot for the information here. And you'll notice that we are comparing temperature and volume. And in this case, the experimenter has chosen a variety of temperatures to measure the volume of a gas. So in this case, temperature is the independent variable and volume is the dependent variable because the volume of the gas depends on the temperature. And after you're done drawing your scatter plot, what I'd like you to do is draw your line of best fit. What I want you to do then is pick 2 points on your line of best fit, not 2 points from the data set you're given here, but pick 2 points far apart. So one to the bottom left hand, because obviously as temperature increases, volume increases as well. So what I want you to do is pick 2 points far apart on your scatter plot and use as much of the grid paper as you possibly can to draw your line of best fit or your scatter plot. And so calculate the slope of the line using y2 minus y1 over x2 minus x1. And then I'd also like you to calculate or figure out what the y-intercept of your line of best fit is. Then I'd like you to write the equation of the line in y equals mx plus b form, and then use that equation to determine when the temperature of the gas when your volume is 0. So here you can obviously see that the volume of the gas is far from 0. I want to know what temperature the gas is when the volume is equal to 0.